Oh,
Good afternoon. I'm Pragnesh Patel. I work for National Institute for Computational Sciences. I'm going to talk about Python for scientific computing and performance computing. In today's talk, I'm not going to cover the basic or introduction to Python, but going to put our emphasis on how being used, how using Python for in different scientific domains as well as uh, supercomputers. I will briefly talk about Python, basically the data types in the Python, what Python. Um, and I will focus more on uh, computing with Python. Then libraries are available in Python to do the scientific computing and high performance computing. Some applications like some of the packages like YT or GPO or as for data analysis, and I will summary of my talk. So Python is a dynamic programming language um, opposed to C, which is the statically compiled language. Um, it is a language and it provides the interactivity. So when you are writing the code, you can see the output of the code. Object-oriented features, so you can uh, implement classes, inheritance, polymorphism, and so on. The one of the thing about Python, it provides so many different packages. So that you write the code from scratch, you can just import that package into your code, and you can use all the functionality available in the package. Example like a matplotlib. Matplotlib provides very nice functionality for plotting. So you just import the matplotlib in your code, and you can use all the functionality available in matplotlib. The another about Python, it provides the function interface. So you can call existing C, C++, Fortran libraries in Python. Easy to learn compared to other languages, and easy to use. One thing you need to worry about Python is it is slower than the compiled languages. There are few alternatives are available, so you can improve the performance of your code, and I will talk about that in my talk. The two versions are available. One is 2.x and another one is 3.x. So current one is 2.1.6, which is the latest version of Python 4 series, and the 3.4.0 is the latest one in Python 3 series. One part about these two different versions in is 3.3 backward compatible with Python 2. So be careful when you are writing the code in 2 or 3. But as for the people, they have written the code in Python 2. So they are facing difficulty when they want to port Python 3. So here is an example of the data. So data type is more than any language, and Python has its own data types like it the integers, floats, comp numbers, basic operation, arithmetic operation like summation, multiplication, divide, and so on. And the Python provides really good functionality for string operation. So here in the example, you can just add the two strings using the plus sign, and you can repeat the string just saying multiply by 3, and it's going to repeat the string 3 times. So you can use the similar operation as you use for integer and float on strings up to level. So in my first slide, I mentioned about Python is a dynamically typed language. That means I say x equal to 1.0 in the next statement. I say x equal to x. Then it's going to uh, allow me to do that. That means now x is a string. It was um, uh, uh, integer. So it does have a type, and when you want to do some operation, it should be computable. So as you see in example, like my here with the integer and s is a string, and you want to combine those two using a plus operator, you cannot do that. So it's multiple types when you want to do some operation on the values. Yeah, and think about the Python is you need to implement a separate function for different data types. Example of add operation is my function where I add x plus y. I either to this function I can pass complex number to this function, I can pass float to this function. See, you have to cut from one data type to another data type before you are doing this operation. While in Python, it's doing it implicitly, so you don't need to worry about version or anything like that. So and because of this, you don't need to write the duplicate code. So the powerful data structure in Python is list. So list arrays in Python index start from 0. And item can be any object. So you can have a list where Mondays can be in that list, and you have the multiple matrices in your list. You and remove items from the list very easily. The index. So many functionality available to work on arrays like sort or array multiplications or slicing, merging two arrays, and so on. So why vision for scientific computing? Some of the reasons why you should consider Python for scientific computing. The most important thing is it provides so many packages. You need to reinvent the wheel. You can use already available packages for your research. And the thing is, it's a good balance between the performance and the time investment. The Python to learn another thing is it's easy to do the prototyping. You easily write the research prototype in Python rather than spend more time implementing the similar thing in C. And are open source and free. And if you want to use some other libraries which are available in other languages, still you can use those libraries in code. It has syntax and as mentioned, it has a fast program development. So here are the different domains where people have been using Python. They have used in biology, astrophysics, particle physics, biology, chemistry, finance, data science, genetics, and so on. And here are a few more, like these are used in plasma simulations, biomolecular simulations, artificial intelligence, science visualization, social sciences. I'm going to cover a few of these domains where I will give an introduction about that package and the functionality of that package. Even Python. So as far as I observed, the scientists and engineers, they don't want to write software, but they just want to solve their problems, because they want to focus more on their research problem rather than worry about how to implement that thing in languages. If they write the software, it must be as easy as possible. And the Python is perfect, easy to learn, easy to use. There are so many packages already available, so already built-in functionalities are there. So it's efficient to implement your algorithms in Python. And great maintenance. It's really good syntax. So it's easy to read the program, and it's easy to manage the program in Python. So here the general scientific tools all available in Python. Really popular one called NumPy and another is called SciPy. So NumPy is provide the array object, and this function you can do so many operations like dense matrix multi, then matrix algebra operations, sparse matrix algebra operations, sparse Fourier transformations, and so on. NumPy is on top of NumPy. It uses the NumPy object and provides the functionality for the statistical computing, mathematical computation, interpolation, optimization functionality, and so on. So Python has really good visualization packages, and one of them is Matplotlib, which is nice 2D graphics functionality for plotting. You can do the bar plot, log plot, scatter plot, very using Matplotlib. Another is the visit. Visit is written in C++. It also has an interface with Python. So if you need to write the Python code, you can Python script for visit, and you just submit the script to visit, and it's going to do the visualization for you. And I'm sure you heard about VTK. That's a visualization tool. Python has an interface with VTK, and you can do a very nicely graphics using interface. As far as performance computing is concerned, there are packages available to do the hypercomputing in Python, and one of them is MPI4Py, which provides interface to MPI implementation. And there are different implementations are available like Intel MPI and H2 and SCI MPI and KMPI and so on. So MPI provides the interface to the libraries available on the system, and you can write the MPI code in Python, and you your code up to few hundred or few thousands of codes. So PATS is mostly sparse matrix functionality, and Python has also the PATC interface. In that, you don't need to worry about how to implement this functionality in MPI. It's already been implemented in C. So you just use this PATC interface with Python, and you call this function. You call these functions within the Python code. And since GPU computing is becoming popular in the HPC domain, there are packages available to do the GPU computing in Python. One of them is called PyCUDA, with the interface with CUDA language from NVIDIA. And the second one is PyOpenCL, which provides the interface with OpenCLI. And IO tool available. So you use the HDF5 code, file from your code in the H5 package, and then and needs a 4 Python package available. You can read CDF data using using Python. Here are the tools and libraries popular in different domains. In biology, the Python is very popular package. modeling, GPOs are two popular packages. Geoscience, Python has different packages. Geoscience domain, GIS, Python, PyClimate, LimPy, and CDEC. Or White is really popular package. AstroPy is also popular package for doing the galaxy simulation or analysis and visualization of astronomical data. And the library is being popular for doing the data analysis. So provides the not exact but similar kind of functionality which you can get using the R or SAS or MATLAB. Provides the statistical functionality, statistical algorithms for Python. And there are so many packages available for finite elements calculation, dynamic systems, and artificial intelligence. There are some packages available which deals with foreign function interfaces, called the C++, Java, MATLAB code from Python. So for this package called Python, which provides the interface with C and Python package. Using that package, you can import the C into Python. C is also popular. And Python, they provide almost similar functionality and import C++ functionality in Python. And Py, that is for Fortran core. If you have Fortran core and you want to use it in Python, you get to package and you can call that Fortran function in your Python. So people really like some of the functionality from R, but so used to with Python programming. There is this package called RPy, so you can get functionality using package in Python. So you can call the MATLAB code from Python, and Java is available for Java to do the kind of thing. Here is the link which gives detail about the very useful in Python, which you need generally in the regular basis to do the programming in Python. And I recommend to this link and look at the packages. So now the NumPy. So today I'm going to give you the information about NumPy, SciPy, and Py, and on applications like IT, GPO, Pandas, PyMol. So now so NumPy is a multi-channel homogeneous array object, and it's the large units of memory to the single object. And using the NumPy, use the parallel computing. You can have MPI code on top of NumPy object, and so the NumPy object structure, it's easy to do the parallel programming using NumPy object. It's most native data types available in Python, like integer, float, complex numbers, and it provides the linear algebra functionality, fast Fourier transformations, random number capabilities, and basic statistics. So think about NumPy and once you have the data in that container, you want to do kind of operation. But in Python, if you don't use package, it's not easy. You have to convert that object into the particular object. So the linear algebra library or random number libraries can understand data type. Using NumPy has solved that problem. you just construct that object, and NumPy is going to deal with the data type conversions or the structure conversion for you. And so the different data types which NumPy supports, like Boolean, integer, 62, 64 bits. On yours, it also supports the float and complex numbers. So here's how you can create the NumPy array. So first you need to import the package in your code. So if you see the second line, you see import NumPy as NP. So I created the as NP as the object, np.array, and then I have this 2-row, 4-column array. And if you select 1, 2, 3, 4, 7, 6, 5. Now let's to make of evenly spaced number over an interval. So let's say np dot line space 100 to 10, and the Python index starts from 0. You see that the interval here is 11. And if you want to create and pre-pop the array with zeros, you can np dot zeros number of the number of columns and create the array for you. Now let the operation. Once I have the array, what I can do with that array? Let's say I have an array with 3 rows and 4 columns, and I want to get the slicing. So you get the reference in row 0. So if I say row equal to a bracket 0 comma colon bracket, and like 1 2 3 4. So that's my first row 0. If you to get the slice of column 0 and column 2, you can a colon and in bracket 0 2, and you get 1 3 9 7 1 5, which are your 0 and column values from all the rows. And thing is, it here saves the, so still it doesn't copy the data. It's still actually referring to the original object. And if you want to have this data, then you have to copy that data into object, and that in that case you will have 2 different objects. One is the original one, and the one in which you operations and create condensed array. And here are slicing example how you can do the slicing. This is the 2D array, and then what you want to access that data, you can access this data. And that's why NumPy is really popular, because it provides this functionality. So you can, once you store data, you can access the way you want. You can access the value using the row index and the column index. Talk about the thing. So that means I want a single operation on elements. So like you have an array of 2 columns and 4 rows, and I want to add 1 to element. In that case, I need to do just plus 1, and it add 1 to all the elements of that array. And as output, it says array 2 3 4 5 9 7 6. So while in C you have to create a loop, and then you have to add 1 element to the another thing is like you want to add 1 to the first row and 10 to the second row. To do that, you say A1 in bracket and then call comma bracket. That way, 1 to the first row and 10 to the second row. And you put is 2, 3, 4, 5, 18, 17, 16, 15. And you many other operations. Similar way, you can raise the first row to the power 2 and second row to the power 3. So so that's we call the broadcasting. You have this single operation, and then you want to apply that operation to many elements. There are few rules for that. One is both your arrays are two-dimensional. The corresponding size have to be either equal or one of them has to be 1. An array with two dimensions says 1, 2, 3, and another is 1 by 2 by 3, and another one is 2 by 3. Compare only trailing common dimension, and in this particular example, you compare 2 by 3. That's why I gave a very brief introduction about what you can do, which base operation you can do when you have the NumPy array object. To learn more about NumPy, here are really nice references. One is from the wiki.sci-fi website, and another one is the NumPy website. So now about the sci-fi. Mentioned before, sci-fi is on top of NumPy and provides the algorithms and mathematical tools. One NumPy provides the data structure layer. Sci-fi functionalities including integration functions, optimization functions, file functions, sparse eigenvalue, and many. Let's the spatial functions. So you to list how many spatial functions are available in sci-fi. The sci-fi you say strong sci-fi. So I forgot to here import the sci-fi, but you need to say import sci-fi. So from sci-fi import shell, and you see all the spatial functions available in sci-fi. Functions, super functions, gamma functions, error functions, polynomial functions, hypergeometric functions, and so on. Look at the sparse matrix function in sci-fi. Import the sci-fi dot sparse, and first let's assume we have the dense matrix, which has the 4 rows. Now you want to add this into sparse matrix, and there is one called CSR underscore matrix, which will convert this dense matrix into the sparse matrix. And now we want to do the sparse matrix multiplication. As you in these slides, I have the dense vector, which is V. So I can A multiply V, and that way I will get sparse matrix dense vector multiplication output. One like about sci-fi is view functionality. So like you want to write some small function, and from Python, you can do in that case. You can use the view from SciPy, and you can run C code in your Python script and run inline code. So as an example, title equal to, and then code, and that in that particular region I have the C code. And how this function? So just say view dot inline the function, the code, and then you pass the parameters to that code. And in this case, it's going to call that function and read values to the Python. And to NumPy, SciPy has also really good documentations and tutorials. Let's talk about the matplotlib. It provides nice 2D and 3D graphic functionalities. Another matplotlib, it provides interactive um, uh, graphics, so you can interact figure. The high quality, in different formats, including PNG, PDF, SVG. As far as the plot functionality is concerned, it provides plots, scatter plots, annual fitting, histograms, and so on. Here is the example of matplotlib. Here I imported matplotlib pyplot and I created object plt, and then I say plt.plot 1, 2, 3, 4 plt.y label some numbers and plt.show. You in your GUI, you also save this as an image, a PDF or PNG. In this plt.plot, I pass 1, 2, 3, 4. I pass any x values. So what it does, when you don't find anything, by default it assumes it's a y-axis value. So that's why the y-axis, the range is from 1.0 to 4.0. On the x, it's to match the y value, and that has 0 to 3 because the Python index starts from 0, so it's the similar like 4 values, but it starts from 0. And y-axis I explicitly specified start from 1 and end 4. Couple of matplotlib histograms. As you see on the axis, it has the value from 40 to 160, and the y-axis it has the probability values. You can do the baseline using norm PDF. And here are the few examples from matplotlib. You can do the scatter plot, do the polar plot, you can do the lag plot, and so on. So these three packages are very big and important packages in Python, NumPy, SciPy, and matplotlib, to do the specific computing. Now talk about how you can do the parallel computing. Use different ways you can do the parallel computing in Python. One is called the threading, where it's useful for certain concurrency issue, but as threading in Python concern, it has this global interpreted lock, and that's why it's not able to use threading in Python. So it is available. If you want to do the processing, one sub-process and the one is called multi-process. So in the sub, it's like the relatively low-level control for spawning and managing, and multi-processing, which is becoming quite popular to do multi-core computation using Python. If you do the distributed computing where you have multiple nodes, in the MPI4 is really handy. You can write the MPI code in Python, and you can run on multiple nodes or on supercomputers. It also the functionality for doing the new computing is two packages, PyCUDA and PyOpenCL, and write the GPU codes. So as it's not to use, but as far as the detail is concerned, it's supported. it doesn't see interprocess combination or doesn't use massive passing, and share memory and state with the process, which is typical to any thread in language. So this example, but I will show you how to calculate pi using the multiprocess and MPI. So multiprocessing, it's added into Python 2.6. It uses to do the communication between the processes. It uses queues and pipes, and to organization, it uses locks. So here is a example of how you can use multiprocessing package in Python and run your code on multi-core architecture. You import the multiprocessing package, and of course, a NumPy is like the basic data structure. So there's a NumPy as well. And once the base this function called mp.cpu_count, which gives you how many cores are available on machine, and then you samplings, and you have this function relates the pi, and call this function is the bottom part of this slide. It has mp.pool and processes. And it's called calc inside function within map function, and map function will call calculate side multiple processes, and it's going to be that function will run by multiple processes and faster results. That results you can just say num mean, and it gives you the mean of the result. So multiprocessor is useful to run your code on multi-core architecture. Then you have the multiple nodes. Multiprocessing package is not useful. UI4Pi, it is the interface to the MPI library, provides most of the functionality available in MPI 2 standards. For scalable, so it doesn't matter which implementation you use. It's mostly compatible with available implementation, and it works best with NumPy data types. You can use other data types as well using MPI 4.5. So should I use MPI 4.5? So if you have numerical calculations, computational intensive algorithms, then think of running on a multiple node and getting the faster result using MPI 4.5. And it's mostly useful on the distributed memory machine. Here I have example run this code. So let's say you have the Python program, which MPI hello world program. How is apprend fnp, sorry, fn5 and you run you call that particular script. In this case, it's going to start 5 instances of that code, but general thing is very popular SPI paradigm, where you have the same program but you want to operate on multiple data. And example in coming slide. And as I mentioned, you don't need the executables, but you are just passing the messages to the different MPI ranks. So to the MPI in your Python, you say from MPI for Py import MPI. In MPS to slice the MPI, you need to finalize the MPI. To do it, you say com equal to MPI.com word. You get the how many number of processors are available in the communicators, get the rank. So these are the operations, big functions in MPI, and then you can build the code used on top of these functions. Then SPMD that in which there is only one source code and written for certain processor, and it's going to different data. So MPI is about moving around the buffers, the row of data. But Python, most of they use NumPy modules, so they are going to move around the NumPy objects, that row block of data. So we already looked at the example of Pi using multiprocessor. Now let's using the MPI for Pi. So need to import the MPI for Pi, and in my MPI I always use NumPy to create an object, and I also random package to get the random numbers. Then you equal to com MPI.com word rank to com.get rank, and then you size using the com.get size, and then there is this block where it does the calculation of Pi for loop, and then Pi equal to row multiplied by divided by number of samples. What to happen is every rank will execute this for loop, and then after each of the data and you data from each rank. So on the bottom of this slide it says Pi equal to com.reduce my Pi, and it says operand equal to MPI.summation. So and it's going to execute by root 0. By default, if you don't specify root equal to 0, the operation execute by all the ranks, and we don't want to do that. We just want to have only one rank collecting the results from the different ranks. That's root equal to 0. Enter and I say rank equal to 0, and print the Pi value. If I rank equal to 0, then we'll print Pi values, and how many ranks you are running, you will see this printf statement that many times. Here are important things about computing. One, the load balancing. Program is inefficient if it's not using all the available resources. So let's using only some of the resources, or few processes are using the resources and processes are sitting idle. That means you have really good load balancing in your code, and you need the speed up in your code because this load balancing issue. Keep in mind is communication expensive. When you do the cast or reduce, as I mentioned in my example, reduce need to get the results from all the ranks. That means it has to get the data from different nodes. It has to go to the interconnect to get the data, and it is expensive. Once you try to access the memory of another node, you interconnect or using the Ethernet or whatever mechanism you use. And so if possible, just try to minimize the communication. Try to use the local data as much as possible within that node for the rank. Now, as you know, GPU computing is also getting popular in HPC. There is available to do that. First of all, if I don't know how much you know about GPU computing, but GPU is the purpose computation using GPU. So GPU initially meant for only graph rendering, but nowadays, because of capabilities and architecture, you can use the GPU for purpose computing, matrix multiplications, or running statistical algorithms on GPU rather than just doing the 3D visualization. The popular is GPU.org. It has in many domains, including modeling, computational engineering, linear algebra, operation, and provided by India, which is called CUDA, Unified Device Architecture. CUDA compiler, it is an extension of C language. Using CUDA software toolkit, you can write the GPU code. The extension of C. So use this library, this toolkit in your Python. Use package PyCUDA. There another API available which is called OpenCL, which does similar things. So you can write a program in OpenCL and run that program on use. But it offers API for Python. It has a for C. So CL in Python, you have to use the OpenCL packages. The CUDA and PyOpenCL both are from the group Denmark. Integrated NumPy in PyCUDA package for to use, even to develop API program in Python, it's preferred to use NumPy object. And here also, if you have object, you can build PyCUDA functionality on top of it and use. In CL, there is a package called PyOpenCL. So you OpenCL program in Python and run on GPUs. Let's talk about some domain-specific packages. So G is schizophrenic structure simulation. It is of the projector augmented wave method, and this is for grid. So that's why it's called GPO, grid projector augmented wave method. The good thing package, it's massively parallel, and it's Python C using the NumPy library. When it's possible, it can use the layback functionality, so that it can use the multi-core architecture as the distributed architecture. Example how GPO package can scale. So as you see, number of cores and the speed up, the linear speed up, it's in the blue. So it has different algorithms in it, and one of 561 the scale that it's really well compared to 102. But his course it's like 15,000 cores or more than that. There is the pack called YT, which is for quantitative analysis and visualization. useful for analyzing and visualizing volumetric motion data from physical simulations and also radio telescopes. It has to many different problems within the astrophysics, and it is built using NumPy, SciPy, Matplotlib. This is an example of galaxy simulation using YT. You see here it uses the gadget and the RAM different data sets, and it uses the visual using YT. If you are from biology domain, then this package called BioPython, which provides the functionality to bioinformatics files into Python data structure. It supports formats like FASTA, Protein Data Bank, BLAST Output, PubMed, and it has to operate on the sequence. It can deal with the alignments. It's the tools for managing the protein structures. Using BioPython, it also interfaces with BLAST and ClustalW package. You can use that functionally using this package in Python. The data analysis library, similar to R and SAS and MATLAB, it is done on top of NumPy and SciPy. It provides two key components, series and data frames. These are the data structures, but these structures are really helpful for this activity. Purpose is provide the tool to data for cleaning the data and modeling it. So that data frame in Pandas, it's like a structure, and it is the order of columns, the row index and the column index, and frame you can do any operations in Python. And the last is PyMo, open source molecular visualization system. The 3D images of small molecules, biological macromolecules such as proteins. It provides visualization along with the high quality image production for papers. The one of the important thing to notice for PyMol is it's for performance and quality visualization. But in terms of uses, it needs of memory. So if you have 4 GB memory, and if you are dealing with large molecules, then may not be enough to run PyMol package on your machine. Here are what you can do with PyMol, and I think for different packages, as in Python increase the performance of programmer, and it provides full data structure to deal with the data. If you can see, then you can get the best both from words like high performance for programmer from Python and performance or performance high performance runtime from C. Different scientific domains, as in astrophysics and biology and chemistry and science and so on. Many packages for high performance computing like MPI for Pi, multiprocessor, PyCUDA, PyOpenCL. And good visualization capabilities, as you see matplotlib. It has all faced with Vision and VTK. So thank you for attending seminar, and if you have any question, please ask.